Hi everyone, we've made this slideshow and video to try and explain how a Solarbloc pump station works. It's a very clever unit, but it can be a bit confusing if you're not used to it, but it has some great built-in design features that allow different designs of systems to be used. The different layouts and built-in controls enable a wide range of solar heating systems to be installed with one model. Not all the solar controllers have these built-in features, but this pump comes with two main layouts which you can use, as you can see in the diagrams below. The pump on the left shows the heat dump layout, and the drawing on the right hand side shows a backup layout. Throughout this video we're going to be talking about the layout you see in front of you now, or what's known as the heat dump side. Although while we're talking about this layout, we're talking about a heat dump mode, it's a bit of a misleading name. The pump is really split into two sections. You've got a primary heating side, shown here on the left, and the secondary heating side, shown here on the right. Both sides are essentially the same. You can set the system up so that any water load can be on either side of the pump, it doesn't really matter. You can have hot tubs, pools, in-floor heating, commercial heating, or normal domestic water heating, or anything else you can think of on either side of the pump. You just need to think through the process and decide what you're wanting to do. Decide which is your primary load, and then this will be the side that takes all the heat produced by the sun. Whatever's left over, you then send through the heat dump function to the secondary side, which can also be a pool or a hot tub or anything else you can think of. For example, normally everybody needs hot water in the house. That's why the domestic hot water tank is always placed in this diagram on the left hand side, or the primary side of the diagram. The domestic tank gets heated up to whatever the maximum temperature you set, and anything else is then sent to the heat dump side to heat your pool or hot tub or in-floor heating. The words heat dump imply that you need to throw away excess heat. However, in reality, all it means is that you're moving the heat from the main solar storage tank, which is the red tank with the coil at the bottom, to the heat dump side, which could be anything else. It can be another tank, it can be a swimming pool or a hot tub. It does this automatically once it reaches a maximum temperature and the heat dump side opens. We'll explain this later on as we go through the presentation. This diagram shows the backup system mode. It's a slightly different layout. This layout is to be used when the size of the solar system is going to be much less than the amount of water that's used by the building. Either in a home or a commercial building, it doesn't really matter. The incoming cold water supply from the main supply is preheated by the solar. If it's not hot enough, then the flow goes straight into the backup boiler to get a boost of temperature before going into the tank to be used by the building. So here's the heat dump layout again. The diagram is missing a number of items that need to be included in all closed-loop hydronic systems. Every province has different plumbing regulations regarding what needs to be installed, so please check with a licensed contractor in your area. However, there are a few items that are common to all systems. All closed-loop hydronic systems need an expansion tank. This is a high-temperature expansion tank that copes with the fluid and fluid vapor expansion during normal operation and during stagnation temperatures. This tank needs to be a special solar expansion tank or rated to high temperatures to cope with the temperatures that the solar water heating system can produce. Also, a pressure relief valve needs to be installed. This will create a release path in case the system exceeds normal operating pressures. Okay, here's how it works. The Solarbloc has a temperature sensor on the roof embedded into the solar collector, so it knows when the sun's shining. So when the sun's warm, the pump turns itself on and starts pumping the glycol water mixture around the system like this. It goes through the collectors where it heats up, comes down into the tank's heat exchanger where it warms the tank up, and the water comes out of the tank cooler and goes back into the Solarbloc where it starts to cycle again. This cycle keeps repeating as long as the sun's shining and as long as there's room to store the heat in the tank. Solarbloc senses when the sun goes down and turns itself off if there's no more heat to collect. The pump built into the Solarbloc is a variable speed pump, so it automatically adjusts how fast it's pumping. So when the sun is very strong in the middle of the day, it pumps faster, and when the morning and evening when the sun strength is lower, the pump slows down. This uses less electricity to pump and makes the whole process more efficient than most solar controllers that use a fixed speed pump. The layout you're looking at here is for a single tank layout. So the water comes in from the cold main supply, goes into the tank where it warms up and then comes out of the tank and goes into the house, into the showers or the washing machines. However, some houses might have a separate tank already installed, an electric or a gas water heater. In this case, the solar system simply added to the existing water tank like this. So the greyed out section on the right hand side of the screen is just showing the heat dump side of this pump system. We're just going to remove it for a few minutes so we can see the screen a little bit clearer. This is how the pump works in the heat dump layout. The 3 ports on the pump station, there's 2 on the left side, here and here, and 1 on the right side, here. The upper left one remains open all the time, but the lower ports on both sides are controlled by the built-in 3-way valve. One of the ports is always open and the other is always closed. When operating normally, they're in the position you see here, with the lower left port open and the lower right port closed. As you can see in the T-junction and the piping here, what this does is allow the flow to go normally through the lower left-hand port. But the heat dump side is closed off because the right-hand port is closed. And when you set the system up, you can specify what is the maximum temperature that you want the tank to be. If it's a normal pressurized hot water tank for a domestic hot water system, this temperature could be set at 90 degrees C as a maximum temperature in the tank. For a swimming pool, you might only want this temperature set at 27 degrees C. Once the tank reaches whatever temperature you've set, the controller activates the heat dump mode. The 3-way valve turns and the 2 lower ports switch positions. Now you can see from the T-junction and the pipe in here that the right side of the system is now open to go through the heat dump, but the left hand side is now closed off. As a quick summary and to finish, I'm just going to run through the sizing of tanks. It's only going to be a quick summary as there are so many variations of tanks that you can use that it's a whole new topic, and hopefully we'll get around to explaining this at another time. Anyway, as a summary, with the Solarbloc it can run 4 to 6 30 tube collectors depending on the layout and how much piping and the friction loss in the system. But on an 80-gallon tank you only want to use a maximum of 1 or 2 30 tube collectors, so 30 or 60 tubes at most. One 30 tube collector in summer will heat an 80-gallon tank to nearly boiling point. If you add a second collector to the tank's normally going to heat up to its maximum temperature by midday. Remember, most of the overheating of the solar systems occurs in summer, and there's no point trying to dump the heat into a home space heating system in the summertime. Even in winter, an 80-gallon tank can be heated to between 30 or 50 degrees C. It depends on the climate where you live. The outside temperature doesn't really affect it. In winter, the hottest tank days are going to be when it's minus 40 degrees outside in Alberta, because if it's that cold and there's usually no cloud cover. In Vancouver, however, there's much more cloud in the winter and the collectors are about 30% less efficient than they would be in Alberta. If you want to install more collectors, then you should really have use for the heat, like a swimming pool or a hot tub, or have larger storage tanks like the one in the picture here. Solar storage tanks can be basically any tank. If you're building this system yourself, you can find locally non-pressurized large plastic tanks that are going to work well for very little money. Or if you go down to a local scrapyard, sometimes you're going to find old milk trucks with 1,000-gallon stainless steel tanks on them, which you could probably buy for less than the cost of a new 80-gallon tank. Some of the pictures here just show some different types of tanks that you can find. There's obviously going to be a bit of modification needed to put these tanks in and to plumb the heat exchangers in, but they're much more cost effective than the pressurized tanks. Anyway, that's it for now. I hope this helps explain a little bit more about the Solarbloc and solar water heating. We did write an article about solar space heating for heating buildings. If you want to get a copy of that, just click here. Thanks very much.